Okay, let's dive right into this. Welcome to today's Explainer, where we are going to unpack a truly fascinating piece of educational research from Chris Powell on why drawing a live diagram completely transforms the way we learn. Listen, if you've ever presented a complex topic and just watched your audience's eyes glaze over the second you click to the next slide, this is absolutely for you. We are going to explore the cognitive science behind presentations and discover why a simple step-by-step drawn sketch is actually vastly superior to that glossy pre-made internet image you've probably been relying on. So here's our game plan for this explainer. We're going to start with the copy-paste trap, head inside the working memory, look at the danger of cognitive overload, unleash the power of live diagrams, and finish up by creating your crib sheet. Let's get to it. Section 1. The copy-paste trap. Now, whether you're a teacher, a corporate trainer, or just someone who gives presentations, we all hit this exact same wall. How do we visually explain complex, interacting concepts without totally confusing everyone in the room? Seriously, have you ever just pasted a massive, fully finished diagram onto a slide simply to save time? Come on, be honest. It's so tempting, right? You think, hey, this glossy internet graphic will do all the heavy lifting for me. But as we're going to see today, taking that shortcut is actually building a massive barrier to your audience's understanding. The research points out a really interesting contrast here, especially when looking at newer presenters and student teachers. On one hand, you have totally valid anxieties, like maybe you're not 100% confident in the subject, you're terrified of forgetting a crucial step while you're standing up there, or let's be real, you're just worried your drawing skills are absolutely terrible. And on the flip side, you have that tempting shortcut, just copying a complete complex image from the web. I mean, it saves time and looks highly professional, but here's the kicker. By leaning on that shortcut, presenters are actually neglecting an incredibly effective way of teaching. To truly get why we need to ditch this copy-paste habit, we actually need to look under the hood of the human brain. Which brings us to Section 2, Inside the Working Memory. And this brilliantly illustrates exactly what we're talking about. Take a look at Daniel Willingham's super simple model of the mind to understand the mechanics of learning. Here's how it flows. For any new information from the environment to stick, it first has to capture our attention. Once it has our attention, it drops into the working memory. Think of this as the active construction site of your awareness. It's where the thinking happens. Finally, if we process that info effectively, it moves down into our long-term memory, which is basically an infinite storage locker for factual and procedural knowledge. But, and this is a massive catch that every single presenter needs to understand, the working memory is a strict bottleneck. Its capacity is incredibly limited. Think of it like a highly strict bouncer at the door of an exclusive VIP club. This bouncer is only letting a very few select pieces of information in at a time. So learning only happens if we successfully guide our audience's attention through this tiny space without completely overwhelming that bouncer. If we just throw a massive rowdy crowd at the door all at once, the whole system shuts down. Nobody gets in. All right, Section 3, Danger of Cognitive Overload. So what exactly happens when that working memory bottleneck gets jammed up? Well, John Sweller's cognitive load theory breaks down the types of strain on our working memory. First up is intrinsic load. This is just the natural, built-in complexity of whatever material you're teaching. For instance, if you're explaining the incredibly complex interacting elements of a weather system like El Niño, that naturally carries a high intrinsic load. It's just tough stuff. Now, managing this load absolutely does not mean dumbing down the content. We aren't cutting out the hard bits. We just need to chop them up into smaller, sequenced chunks so we can actually explain them effectively. Then we have the second type, and listen, this is the true enemy of understanding, extraneous load. This is basically any unnecessary distraction that strains the working memory. Think irrelevant graphics on a slide or overly convoluted instructions. When we introduce extraneous load, we are literally distracting the working memory from the exact thing it's actually trying to comprehend. And that drastically kills the chances of that information ever making it down into the long-term memory. And honestly, this brings us right back to that copy-pasted internet image. When you slap a complex, fully baked diagram on a screen, you accidentally trigger what's known as the split attention effect. Your audience is trying to listen to your voice while their eyes are frantically darting all over this massive diagram trying to figure out which exact part you're even talking about. Plus, those pre-made images usually have extra details meant for a totally different context, which causes the redundancy effect. You are literally forcing their brains to process useless data, overloading their working memory, and just stopping learning dead in its tracks. So how do we fix this? Section 4. The power of live diagrams. Okay, let's look at the solution. I'm actually going to physically demonstrate this superior technique right here on screen by creating a live segmented diagram. Now, what's really interesting about this slide is how incredibly simple it starts. Instead of throwing a chaotic, full-blown global weather map at you all at once, we are starting with just step 1 of the Hadley cell. Boom! Just solar radiation hitting the Earth's equator. By presenting just this one visual element, while I verbally explain that solar energy is highly concentrated here, I'm grabbing your absolute undivided focus. Your working memory is perfectly managing this one single chunk of information. Easy! Let's move on and see how this builds. We remove the solar radiation lines because, hey, we've already processed that. And we introduce step 2. We add red arrows to represent that warmed air rising, and we label it low pressure. See what's happening? I am actively giving your working memory time to organize its thinking. You hear my words, you see the corresponding action magically appear on the screen, and you easily process this new step without getting distracted by whatever comes next. And finally, we reveal the next chunk. What happens when that warm air rises? Well, it cools and condenses. So we add in the clouds and we introduce the specific terminology, the intertropical convergence zone. Look at that. We literally just built a complex geographic model together, piece by piece. Do you see how much easier it is to grasp a tough concept when the intrinsic load is actively managed through this progressive revelation? You weren't overwhelmed because you didn't have to decode the entire massive system all at once. And look, this isn't just a neat presentation trick. This technique is rooted in highly proven science. Educational psychologists Mayer and Moreno call this segmenting, the method of breaking processes down into sequenced steps. On top of that, researcher Alan Pavio argued for something called dual coding. By aligning our verbal explanations with matching step-by-step imagery, we effectively cheat the working memory's limits. We are using both the linguistic and visual channels of the brain simultaneously. That completely avoids the enormous burden of trying to hold a complex, static image in your mind while also trying to listen to the speaker. Which leads us to our final part. Section 5, creating your crib sheet. Now you might be wondering, what if I'm standing up there and I literally just blank on what to draw next? Well, here's the secret. Experienced presenters and educators rarely just wing it when explaining intricate systems. They use carefully planned scaffolds, exactly like this crib sheet created for the Hadley cell we just looked at. Notice how it explicitly links very specific verbal cues to very specific drawing actions. It tells you exactly what to say and explicitly when to draw those red arrows or when to write down a specific term. It completely takes the pressure off of your own working memory as a presenter, allowing you to just focus on your delivery. So the crucial point here is that producing one of these crib sheets actually forces you to become a fundamentally better teacher and presenter. Preparing a live diagram makes you ask the essential pedagogical questions before you ever step in front of an audience. You literally have to ask, what is the absolute starting point for this explanation? What specific key terminology is actually needed? What do they already know, and what misconceptions do I need to navigate? What analogies can I use, and what case study provides a concrete example? Creating the sheet means you are thinking incredibly deeply about your subject knowledge and how to strategically communicate it. Which brings us to our final takeaway. Look, copying and pasting a beautifully rendered image from the internet might look a little prettier on a slide. And sure, it might seem to save you a few minutes of prep time. But a live, segmented diagram, that actually aligns with how the human brain fundamentally functions and learns. By actively managing that cognitive load, you aren't just flashing information at people. You are genuinely guiding their minds to truly understand it. So I leave you with this question to chew on. Will your next presentation cater to mere aesthetics, or will it cater to the human mind? Thank you so much for exploring the fascinating cognitive science of live diagrams with me today in this explainer. Until next time, keep learning and keep explaining.